Welcome back to the session Inverse Laplace Transform. In this session, we shall discuss the method of finding the inverse Laplace transforms of functions using the properties of Laplace transform. Consider the function f of s as f of s is equal to 1 by s into s square plus a square. We have to find L inverse of this function. We have the property of Laplace transform. If Laplace transform of f of t equal to f of s, then the Laplace transform of integral from 0 to t f of t dt is equal to 1 by s into f of s. Now, taking the inverse Laplace transform, we get if L inverse of f of s is equal to f of t, then L inverse of 1 by s into f of s is equal to integral from 0 to t f of t dt. That is, if we have an inverse Laplace transform of a function f of s, then we can find the inverse Laplace transform of the same function divided by s as the integral of this f of t between the limits 0 and t. Now, consider this function. Here we can rewrite this function as 1 divided by s square plus a square divided by s, which is of the form f of s divided by s, or 1 by s into f of s, this form. Here the given function can be taken as some g of s, which can be expressed like this, which is of the form f of s divided by s. Now, we have to find inverse of this function, means we have to apply this property, which means that integrate f of t, where f of t is the inverse Laplace transform of this numerator function. Here it is 1 by s square plus a square between the limits 0 and t. With respect to t, the integration is with respect to t. First of all, we have to find f of t. F of t means the inverse Laplace transform of the numerator function. Here it is 1 by L inverse of 1 by s square plus a square, that is 1 by a sin a t. Therefore, by this property, L inverse of 1 by s into s square plus a square can be written as integral from 0 to t, this is taken as f of t, integral from 0 to t 1 by a into sin a t dt. That is, 1 by a can be taken outside because the integration is with respect to t. Integral sin a t means minus cos a t divided by a between the limits 0 and t. That is equal to 1 by a into a in the denominator, that is 1 by a square. into, when we use this upper limit, we get minus cos at itself. This negative sign can be taken outside. Therefore, cos at minus, when t equal to 0, this will become 1. Cos 0 is 1. That is 1 minus cos at divided by a square, which is the inverse Laplace transform. We just used this property of transform of integrals. Considering the inverses of this property, we can take L inverse of 1 by s into f of s as integral from 0 to t f of t dt, where t is the inverse Laplace transform of f of s. Now consider another example. Yes, by consider this function s divided by a square plus a square the whole square. We have to find the inverse Laplace transform of this function g of s. Let we use f of t as the inverse Laplace transform of this function. We denote L inverse of s by s square plus a square the whole square by f of t. Then we have to find f of t. Now f of t divided by t can be written as, we have the property, if Laplace transform of f of t equal to f of s, then Laplace transform of f of t divided by t is, when we divide f of t by t, we just integrate f of s between the limits s and infinity. This is the property of division by t in the Laplace transform. Consider the inverses. That is, if L inverse of f of s is equal to f of t, then L inverse of integral from s to infinity f of s ds is equal to f of t divided by t. Therefore, here f of t is L inverse of s by s square plus a square the whole square. Then f of t by t can be written as L inverse of integral s to infinity s divided by s square plus a square the whole square ds. We have to integrate this function between the limits s and infinity. That's equal to L inverse of, in order to integrate this function, we have to make in the numerator 2s, because the denominator function is s square plus a square the whole square, and the derivative of this function s square plus a square is 2s. Therefore, we have to make 2s in the denominator. We multiply both numerator and denominator by 2. Therefore, we can write this as L inverse of 1 by 2 into integral s to infinity 2s divided by s square plus a square the whole square ds. This is equal to 1 by 2 into integral 2s divided by s square plus a square the whole square means integral s square plus a square raised to minus 2s ds. That is equal to s square plus a square raised to minus 2 plus 1 divided by minus 2 plus 1, which is s square plus a square raised to minus 1 divided by minus 1, that is minus 1 by a square plus a square. Therefore, this is equal to 1 by 2 into L inverse of minus 1 divided by a square plus a square. Which is equal to 1 by 2 into here the limits are s and infinity. When we apply infinity, this is equal to 1 by 2 into L inverse of this minus sign can be taken outside. When s tends to infinity, this will become 1 by infinity means 0, it tends to 0, minus 1 by a square plus a square. When we apply the lower limit, yes, the term is 1 by a square plus a square. That is equal to, here minus 1 by 2, here negative of 1 by a square plus a square means 1 by 2 into L inverse of 1 by a square plus a square. That is equal to 1 by 2 into L inverse of 1 by a square plus a square is 1 by a sin at. Therefore, 1 by 2a into sin at. That is f of t divided by t is equal to sin at divided by 2a, which implies f of t is equal to t into sin at divided by 2a. That is f of t means L inverse of s by s square plus a square. We denoted L inverse of s by s square plus a square by f of t, which is equal to t sin at divided by 2a. Now consider another example. Consider the function s square divided by s square plus a square the whole square. We have to find the inverse Laplace transform of this function s square divided by s square plus a square the whole square. This can be written as s into s divided by s square plus a square the whole square, which is of the form s into a function of s. Now we have the property of Laplace transform, that is the transform of derivatives, Laplace transform of f dash of t, the Laplace transform of the derivative of f, which is equal to s into f of s minus f of 0, where Laplace transform of f of t is equal to f of s. Now consider the inverse transforms. We can write L inverse of s into f of s minus f of 0 is equal to f dash of t, where L inverse of f of s is equal to f of t. Now, if f of 0 equal to 0, we can write this as L inverse of s into f of s is equal to f dash of t for f of 0 equal to 0. Here, take f of s as s by s square plus a square the whole square means L inverse of s by s square plus a square the whole square is equal to, in the previous problem we found that L inverse of s by s square plus a square whole square equal to t into sin a t divided by 2a. Therefore, by this property we can write L inverse of s into f of s is equal to f dash of t, where f of 0 should be 0. Here this is f of t. F of 0 equal to 0 into sin 0 means 0. Therefore, this condition holds, and by this property we can write L inverse of s into s by s square plus a square the whole square means s square divided by s square plus a square the whole square as f dash of t means derivative of this, that is d by dt of t sin a t divided by 2a, which is equal to this 1 by 2a can be taken outside because the derivatives with respect to t, this is equal to 1 by 2a into here t into sin a t. We can use the product rule of differentiation, that is first function into derivative of second, t into cos a t into a plus sin a t into derivative of t is 1, that is equal to 1 by 2a into a t cos a t plus sin a t. This is the inverse Laplace transform of s square divided by s square plus a square the whole square. Consider the function g of s is equal to 1 by s square plus a square the whole square. We can write this function as s by s into s square plus a square, that is equal to 1 by s into s by s square plus a square, which is of the form 1 by s into f of s. We have the property of Laplace transform. The Laplace transform of integral from 0 to t f of t dt is equal to 1 by s into f of s, where f of s is the Laplace transform of f of t. Here L inverse of f of s, that is L inverse of s by s square plus a square is equal to cos a t. Sorry, here the whole square, the denominator s square plus a square the whole square. Therefore, the inverse of s by L inverse of s by s square plus a square the whole square is 1 by 2a t sin a t. By this property, we can write L inverse of this function multiplied by 1 by s, which is 1 by s square plus a square the whole square. That is L inverse of 1 by s square plus a square the whole square is equal to integral from 0 to t 1 by 2a t sin a t dt. By this property, consider the inverses. We can write L inverse of f of s by s, or 1 by s into f of s, as integral from 0 to t f of t dt, which is equal to 1 by 2a into, consider the first function as t and the second function is sin a t, t into derivative first function into integral of the second, that is minus cos a t divided by a, minus derivative of t is 1 into integral of this minus cos a t divided by a is minus sin a t divided by a square between the limits 0 and t, which is equal to 1 by 2a into, when t is equal to t, this term is minus t cos a t divided by a. Here minus of minus is plus sin a t divided by a square. When we apply the lower limit, these two terms will become 0. Therefore, this is equal to, we can write like this, 1 by 2a cube into sin a t minus a t cos a t. This is the required inverse Laplace transform of this function. Now consider the function log s plus 1 divided by s minus 1. We have to find L inverse of log s plus 1 divided by s minus 1. Let it be f of t. Now we have to find f of t. We have the property Laplace transform of t into f of t is equal to minus 1 into d by ds of f of s, where f of s is the Laplace transform of f of t. Taking the inverse transforms, we can write L inverse of minus 1 into d by ds of f of s as t into f of t. Therefore, from here we can write t into f of t as L inverse of minus 1 into d by ds of log s plus 1 by s minus 1. That's equal to L inverse of, this minus 1 can be taken outside, L inverse of d by ds of, here we can use logarithm of a by b equal to log a minus log b, that is d by ds of log s plus 1 minus log s minus 1. L inverse of this, that's equal to minus 1 into, here d by ds of log s plus 1 means 1 by s plus 1 minus derivative of log s minus 1 is 1 by s minus 1. That is t into, here L minus 1 into L inverse of this t into f of t equal to minus 1 into L inverse of this, that is equal to minus 1 into L inverse of 1 by s plus 1 is e raised to t minus L inverse of 1 by s minus 1 is here e raised to minus t, in this case e raised to t, that is equal to e raised to t minus e raised to minus t. Minus 1 into this means e raised to t minus e raised to minus t. The left hand side it is t into f of t. This e raised to t minus e raised to minus t can be written as 2 sin h t, because sin h theta equal to e raised to theta minus e raised to minus theta all divided by 2. Therefore, t into f of t equal to 2 into sin h t, which gives f of t as f of t equal to 2 into sin h t all divided by t. That is the inverse Laplace transform of log s plus 1 divided by s minus 1 is 2 sin h t divided by t. With this example, we have to come to conclude this session. Thank you for watching this class. Have a nice day.